This is Algebra 2 at Trig, 3C.1a. We're solving rational equations by using cross products, cross multiplying. You can use cross products to solve rational equations. Now, a rational refers to a fraction, typically with an x either on top or bottom. Rational. Equation requires it to have an equal sign. And when we have a rational expression on each side of the equal sign, then we can use cross products. That's when cross products is appropriate. When you have a fraction on both sides of an equal sign. One thing you need to be sure is that the denominator is never going to equal what? What are we always afraid a denominator might equal? What can't a denominator equal? It cannot equal 0. So when we get our answer and we plug it back into the denominator, it can't equal 0. Otherwise, we're fine. We can check our work if we want. We'll go ahead and do that. So here we have two fractions. I can show you why cross products works. If you multiply the same thing to both sides of an equal sign, so your x minus 2 is going to cross off, and here you would have to multiply it. We'll just leave it there for a moment. And then we'll multiply by the next denominator. And we'll multiply that to both sides. And when we do that, they cross off. So now you're left with 5 times 2, which is 10x. 5 times 2, which is 10. 12x minus 24. You don't have any denominators. We don't want denominators. So don't try to get common denominators here. We're trying to get rid of the denominators. Notice that we have the same type of x. It's x to the first power. So in this case, we're going to get our x's by themselves. So we have 2x. And we're going to move the constant numbers to the opposite side of the equal sign. Divide by 2, and we get x equals 7. When I plug 7 in, I do not get 0 in the denominator. 7 minus 2 is not 0. 2 times 7 minus 2 is not 0. So this could be an appropriate answer. If you want to check to see if it's the exact answer, you can actually check your work. 5 and 7 minus 2, that's 5 over 5. 12 and 7 times 2 is 14. 14 minus 2 is 12. 5 over 5 is 1. 12 over 12 is 1. Hey, it worked out perfect. Now you've done two things. You've shown your work on how you got your answer. You verified the denominator was not 0. You can be done there if you want. And you checked your answer to be positive that 7 was correct. So we plugged our 7 in. So we had 5 divided by 7 minus 2. 7 minus 2 is 5. So 5 over 5. 12. And 2 times 7, which is 14. 14 minus 2 is 12. That's how we checked it. Now, this is really busy. This has a lot of extra steps that we don't need to do. Let's look at the cross multiplying part. Essentially, that's what we did here. We took the x minus 2 and we multiplied it to the 12. We took the 2x minus 2 and we multiplied it to the 5. So that's where cross multiplying happens. So from now on, you don't have to break it into separate steps. We just cross multiply. I just didn't want you to think that it's magic work. It's actually the normal work. But this is the shortcut way to do it. So you just cross multiply. I like to circle to show what I'm doing. Distribute. And then because I have the same type of x's, x to the first power, I can just move everything over to the same side of the equal sign. I get x equals 14. And notice my denominators do not have x's in them, so they cannot ever equal 0. They're just 7 and 15. And then if I was interested, I could check my work, plug 14 in, and I get 14 over 7. That's 2. And I get 2 times 14, which is 28, and 2 more is 30 over 15, and that's 2. So that works. If you want to check your work to know if you did it right, you can easily check your work. I cross-multiplied right away here just as a shortcut. I did all this extra multiplying on this side to show you what cross-multiplying is doing. You can't just take a denominator and move it to the other side like we did here. It's that we actually multiply the left side by 7 and the right side by 7, and the 7's crossed off, just like we did here. There's actually a lot more steps that you're doing. But cross-multiplying is the shortcut. And you guys like shortcuts, so let's just do shortcuts. What do you see that's going on here with this problem? What's going to happen with this one? We're going to get an x squared. You need to be sure to distribute it both to the 2x and the 3. Now we have an x in both of them. Now we look at this one and we notice that we have different types of x's. We have an x squared and we have an x. We didn't have that before. Before, we got our x's on one side and our constants on the other. Now, because we have two different types of x's, you got to be observant to that, we need to move all our numbers to the same side of the equal sign. We need to make it equal to 0 on one side. And then I notice that I have even numbers for all of those, so I'll divide both sides by 2. That might help you in factoring. So I notice that I have my parentheses that multiply to be x to give me x squared, and then two numbers that multiply to be 5 but add to be 4. So I get x equals 5 and x equals -1. Do either of those answers give my denominator a 0? You don't need a calculator for this. You just plug in a 5. 2 times 5, that's 10 minus 3. Is that 0? Definitely not. -1. 2 times -1 is -2 minus 3 more. That's not 0. Then you're fine. Those should be the correct answers. If you want to verify they are the correct answers, then go ahead and plug in your numbers. Plug in a 5. 5 plus 2 is 7. 10 minus 3 is 7. 5 over 5, that's 1 equals 1. Hey, that worked. Do the same thing with -1. -1 plus 2. -2 would give you a -5 on bottom, I believe. And that's going to be the same thing as -1 over 5. They're the same fraction. It doesn't matter where the negative is, top, bottom, middle, whatever. That worked. Both answers work. That's the best way to know if you have done your math right. Okay, letter D. What comes to your mind here? What do you see? What might you do first? We want to cross multiply. A lot of people look at this one and say, hey, I'm going to factor that. But that's not going to help us in this type of problem. Don't factor first. That's what we used to always do. Factor first. But here we're going to cross multiply. So 1 times this trinomial and negative 6 times p minus 1. Some people may say to factor this and then you can reduce a little bit and it works out awesome. But that can also cause you troubles in other situations, so I'd suggest not crossing it off like that. So, negative 6p, positive 6. That's the spot people are going to make a mistake. It's a negative 6 times a negative 1 is a positive 6. Then I have 2 different types of p's, so I have to bring them all over to the same side. And my constants. I have to make it equal to 0 on one side. So that's p squared plus 3p minus 4. And that can be factored. I get p plus 4, p minus 1. So I get an answer of negative 4 and I get an answer of positive 1. Do either of those make the denominator 0? When you plug in a 1, 1 minus 1 is 0. That's what the 1 means. If you have a positive 1, 1 minus 1 is 0. So that's going to be an extraneous solution. You plug in a negative 4, even if you plugged it into this side, positive 16, positive 12 plus 2, by plugging in your negative 4, that's not 0. Then that's fine. You can check your work if you want. Might get a little messy, but I'll do it with you. We have 1 over negative 4 minus 1 more, which is negative 5. We have negative 6. Plug in a negative 4, you get a positive 16. Plug in a negative 4, you get a positive 12. That's 28. Plus 2 more, which is 30. So either you're trying to figure out, can 6/30ths reduce? That's one way you could do it. And you might notice that 6 goes into both of those. Hey, it works. Or another way that you can do it, you might like this way, if you have a calculator available. You can actually cross multiply and say 5 times 6, or if you want to call it negative 6, 5 times negative 6. And 30 times negative 1. Hey, you get the same answer. That means the fractions are equivalent. Okay, let's come down to letter E. Go ahead, pause the video, give this one a try, see what you find. Then, of course, I'll work it out. All right, let's take a look. We'll cross multiply. We get x and 2x minus 5. I suggest writing it out. Don't skip that step. Don't try to FOIL it all in your head. More mistakes happen that way, but if you can handle it, distribute. Don't forget that it's x times 5 also. Now this has to be the full FOIL, so 3x times x, 3x times 2, which is negative 6, then another negative 6, and negative 6 and negative 2 makes 12. Two different types of x's, so I'm going to bring all my like terms together. I need to make it 0 on one side. Then we can factor that apart. X equals 3, x equals 4, by using the zero product property. Plug a 3 in here and you get 3 over 1. Plug a 3 in here and you get 3 over 1. That works. Same thing happens with the 4. So you can check them if you like. Every single question, you should definitely verify that your answers do not make the denominator 0. Denominator 0. That's what you have to check. Then, if you'd like to verify that you didn't make any silly mistakes, then you could actually take time to plug them in. Like I've shown you before. This is a 3. So I'm going to plug the 3 in for the x. And I'm going to plug a 3 in for the x. 3 minus 2 is 1. I'm going to plug a 3 in for the x. 9 minus 6, so that's 3. And plug a 3 in for this one, which is 6 minus 5. This time it reduced down to the exact same. Made checking it super easy. That wasn't always true, right? This one, the fractions were not exactly the same, but they meant the same thing. And then this one was really tricky to test. You have to reduce the fraction. But this one is pretty simple. And if you want to check the 4 also, you got to redo it. 4 is the top number. 4 minus 2 is 2. Plug in a 4, which is 12 minus 6, which is 6. And 2 times 4, which is 8. Minus 5, which is 3. And they both reduce to 2. You can check your work to be sure you've done it right. Okay, these are you tries. I would encourage you to pause the video, work through these, then come back and see how it went. I'm going to cross multiply. Distribute. We have the same type of x's because they're to the first power, both of them. So we're going to bring them over to the same side. We're going to move our constants over to the same side. That's 50 equals 5x. Divide, that gives us 10. And if you would like to plug that in, you get 7 over 10 minus 3, which is 7. 12 over 10 plus 2 is 12. And that's 1 equals 1. So that works. And our last one. Going to distribute. Need to be sure to distribute it into your parentheses correctly. Different types of x's here. So now this is the type that we need to make equal to 0. I notice that all the factors are even, so I can divide that out by 2. I use the term divide here because we can actually divide it and lose it. We don't have to worry about saving it as a GCF because we're just solving for x. We don't care about the extra multiples. And then the zero product property would make that 8, and it would make this 1. Neither of those make the denominator 0. 1 makes it 1 plus 1. That's 2. That's not 0. That's okay. And you could take your time to check it if you wish. Our last question. It costs a manufacturer $50 to make a tennis racket. So I like to think about that as all the supplies. The string, the strapping, the tension wire that goes in between to have the ball actually hit the tennis racket. All that individually costs money. It's about $50 for every racket. Now, what's going to turn it into and tighten it down and all that type of stuff, that's the $25,000 machine that you're making, that you have. So we're going to let x equal the number of rackets made. That's what x is going to stand for. It's always good to know what your variable stands for. So for every $50, actually for every x, we're going to spend $50. So it's 50x. It's the 50 is going to be repeated again and again because for every racket that you make is $50. Plus you have the $25,000. So that's the cost. So if you want to think about what this means, if you had one racket that you're making plus the $25,000 machine, sounds a little crazy, it's going to cost you $25,000 and the $50. That's a pretty expensive tennis racket. Well, if you were going to make 2 tennis rackets, each at $50 a piece, you also need the machine that helps you make the tennis racket. You've now done $25,000 and the extra $50, but you're making 2 rackets, so the average cost is only $12,000. It's still a little expensive for my taste. So let's say we make 10 tennis rackets plus our $25,000. That's going to be $25,000 plus the extra $500, so $25,500. But we're going to divide that by the 10 because we made 10 rackets. So every racket is worth $2,500 and $50. Our question is, when is it going to fall all the way to $75? Well, we got to make more than 10, don't we? So we need to do the average. The average is when we divide it by x. Did you notice that every time I divided it by the number of rackets we made? That's the number x. Trying to get you to understand why it's set up this way. And we want this fraction, we want this average to equal 75. If you make this into a fraction, then cross multiplying can make a lot of sense because you have two fractions with an equal sign in between. Nothing happens to this side. And this side becomes 75x. We have one type of x, so we can just move it over. Divide by the 25. 25 goes into 25,000 1,000 times. So that tells us that we need to make 1,000 rackets. So if we had each racket that we make be worth $50, so 1,000 rackets at $50 plus the $25,000 fee for the machine to make it, we're actually got to come up with $75,000 of it to do that. But when we divide it to find the average cost of every racket, the rackets are the cheapest price we've checked. So you can always check your work.